Hey everyone, welcome back to another LeetCode problem solving video. Today we are tackling a wonderful array manipulation question LeetCode 228 summary ranges. The problem gives us a sorted array of unique integers. Our goal is to find the smallest set of ranges that cover all the numbers perfectly. If numbers if numbers are consecutive like 0, 1, and 2, we group them together into a single range string 0 to 2. If a number stands completely alone without neighbors like 7, we just output it by itself as 7. This is the fantastic problem for mastering pointer tracking and sliding windows inside an array. Let's first talk about our intuitive strategy to solve this, and then we will jump straight into the code. So now, because our input is already sorted, consecutive elements are guaranteed to sit directly right next to each other. This means we can solve this problem elegantly in a single pass from left to right. Our core approach relies on tracking 2 points for each interval, a start value and an end value. We pick the first available number as our start. We then look ahead at the next number. If the next number is exactly one greater than our current number, the consecutive chain is continuing. We keep incrementing our pointer forward until that chain breaks. The moment the consecutive chain breaks, we lock in our end point. If start and end are the same, it means it's standalone number. So we format it by itself. If they are different, we format it with an arrow like start, arrow, end. Then our loop naturally transitions to discover the next chunk. Now the strategy is clear. Let's see how this translates into C++ code block by block. So to start off, we define our function which returns a vector of strings. We immediately initialize an empty string vector called res to hold our final formatted intervals. Right after, we set up a standard for loop using index I to scan through the array from start to finish. So let's do that. So vector string res, okay, and then for loop int I equals to 0, I less than nums dot size and I plus plus. Perfect. Now at the beginning of each iteration, we are looking at a brand new potential range. So we immediately capture the current number nums of I and store it in a temporary variable called start. So let's do that. So int start equals to nums of I. Okay. Now we need to find where this consecutive sequence ends. We use a nested while loop. This loop checks two essential conditions first. It ensures we don't accidentally run out of bounds of the array. Second, it checks if the next element, that is nums of I plus 1, is exactly equal to our current element plus 1. As long as this holds true, we increment our index I to stretch our current range forward. So let's do that. While I plus 1 less than nums dot size and nums of I plus 1 nums of I plus 1 equals nums of I plus 1. Okay, then we will plus plus I. Now the moment that while loop stops, our index I is sitting right on the very last valid element of this consecutive block. We capture this number and store it in variable called end. So now int end equals to nums of I. Finally, we just need to format our string correctly based on what we found. We check if start is equal to end. If they match, it means it's a standalone number. We convert it to a string using to underscore string and push it directly into our resultant vector. So if start equals end, then res dot push underscore back, then to underscore string start. Right? Now, if start does not equal end, we have a valid multi-number range. We build a custom string combining start, an arrow symbol, and end. Then push that entire string into our result vector. Once the outer for loop finishes scanning the entire input array, we simply return res. So else res dot push underscore back, then to string and start. Here little mistake is there, to underscore up, and then plus, as we have to add the arrow also, so we will add the arrow, and then again plus to string end. Okay, and now we will just return the resultant. Okay, so now let's run and check whether it is passing the given two base cases or not. Okay, sorry, in semicolon is missing. Oh, sorry. Let's wait for a second. Okay, so perfectly, our base cases are running perfectly. Now let's discuss about the. Now let's try run it first, and then we will discuss about the complexities. So now let take the example one to see exactly how our pointer moves. Now iteration 1. We start at I equals to 0. Nums of 0 is 0. So start equals to 0. We enter the while. Is nums of 0 plus 1 equals to nums of 1? Yes. 0 plus 1 equals 1. We execute plus I becomes 1. Loop continues. Is nums of 1 plus 1 equals nums of 2? Yes. 1 plus 1 equals 2. We execute I becomes 2. Loop continues. Nums of 2 plus 1 equals nums of 3. No, 2 plus 1 not equals 4. This while loop breaks. We set and equals to nums 2, which is 2. Since since start which is 0 not equals to end which is 2, we post 0 arrow 2 into our result vector. The outer for loop automatically increments I to 3 for the next round. Now I equals to 3. Nums of 3 is 4. So start equals to 4. We check the while loop is nums of 3 plus 1 equals nums of 4. No, 4 plus 1 not equals 7. The loop skips entirely. We set n equals to nums of 3 which is 4. Since start which is 4 equals n which is also 4, we push 4 into our result. The outer for loop increments I to 4. Now I equals to 4. Nums of 4 is 7. So start equals to 7. The while loop condition I plus 1 less than nums dot size fails because there are no elements after 7. The loop skips. We set n equals to nums of 4, which is 7. Since start of 7 equals end of 7, we push 7 into our result. The outer loop finishes. Our final returned answer is 0 to 2, 4, and 7, which is perfectly correct. Now let's submit and check whether it is passing all the test cases or not. Okay, so it's perfectly working. Now let's quickly discuss about the complexities. So the time complexity. So even though there is a nested while loop inside a for loop, notice that our index I is strictly moving forward. We never step backward or double scan any number. Every element in the array is visited exactly once. This gives us a highly optimal linear time complexity of O of n, where n is the number of elements in the array and the space complexity. So aside from the vector used to return our final string intervals, we are only utilizing a couple of constant primitive variables that are start and I. Therefore, our auxiliary space complexity is a flawless constant that is order of one space. And that is how you solve summary ranges like a pro. Keeping firm control over your index pointer lets you process group constraints seamlessly. If this block by block breakdown and visual diagram help the logic click for you, make sure to slam that like button, subscribe to the channel for more clean LeetCode walkthroughs, and let me know if you have any kind of doubt in this video in the comments section. Keep grinding those problems and I will see you in the next problem.